Um, hey folks, thanks for tuning in. I am Dhairya. I am a software engineer at IBM and I am part of the CephFS team. I mostly work with MDS client and the NFS module. So before jumping into the topic, the new interface that we have in the Libcephfs, we will first take a look at what is the issue with the default interfaces in Libcephfs. So the major blocker is that the default interfaces are all blocking in nature, meaning that there would be a problem for file system gateways like NFS-Ganesha because of the synchronous behavior. This leads to high waiting time and a thread contention. And in cases of long I/O, because of maybe the network is laggy or the I/O is huge, the thread can spend a lot of time in the idle state, waiting state, which is definitely not good. Hence, the scalability takes a hit, and because of this, Frank Fills at NFS-Ganesha led to the development of Async I/O, the asynchronous I/O interface within Libcephfs. Let us first see the difference between what we have on your left-hand side and what we have as a new interface. So as you can see, when the NFS-Ganesha client or any other file system gateway, which is making use of, which is basically attached with Libcephfs, has a read call to the Libcephfs, the worker thread is blocked for the entire duration of the I/O. In this case, it's read, and it is only unblocked when the I/O completes. But not with the Libcephfs, the Async I/O. We have the NFS-Ganesha client, having a async read going to the Libcephfs. Now what happens is Async I/O says, hey, I have received your request. And this basically means that NFS-Ganesha client is free to relieve the thread from the task. And the the Libcephfs pings back the client again when the I/O is complete, and that's how it goes. Let's see how this is done in detail with this diagram. So as you can see, we have the NFS-Ganesha client, and it sends a async I/O call to the Libcephfs via RPC scheduler. Now the RPC scheduler is the part of NFS-Ganesha client code, which is a scheduling mechanism for the NFS-Ganesha client. It spawns a thread. The worker thread then sends the async I/O call to Libcephfs. When it reaches there, the Libcephfs callback is registered with Libcephfs, and this context is what it makes this interface asynchronous. Once that is done, it acts back the NFS-Ganesha client, which makes the RPC scheduler suspend the task and free the worker thread. And if we take a look at what's going on at the Ceph side, we have Libcephfs sending the call to the object cacher or filer with context, obviously. So context over here is a callback mechanism in Ceph. So object is passed with the I/O call, which basically then does a underlying Rados call for the I/O. When the I/O is done, the context completion takes place in the Libcephfs, and the callback is invoked at the client side. Once that is done, there's a resume task, which is ordered by client to the RPC scheduler, which then sends back the response to client. FY folks, RPC scheduler would just not send the response back to the client directly. There are a lot of layers that I have intentionally omitted to keep this diagram async I/O centered. In reality, RPC scheduler would send the response to protocol layer, which basically completes the building up of the response before sending it to the client. Just FYI. So that's how this async I/O works. So what do we get? We would benefit a lot with the low latency operations. There is low thread contention, and obviously the throughput is high, and so is the scalability. We have been enhancing and hardening the interface, the Async I/O interface, quite a lot. We have been extensively testing this interface. We have uncovered a lot of bugs. We have fixed them, and the patches are merged already. We have FS Suite in Teuthology that now runs with FIO workload with the NFS-Ganesha test cases, with or without object cacher enabled. It has helped us to uncover a lot of bugs, and the fixes are underway. Code cleanup is another priority that we have to keep the code modular and manageable. There are some ongoing improvements. One such improvement is to implement zero copy with the I/O interfaces in Libcephfs. This doesn't necessarily mean just async I/O, but also the synchronous I/O interfaces. It's a bit hard to do pure zero copy, but the efforts are to minimize it as much as we can. So we have the pull request, which is by Frank Fields. This PR is currently work in progress. Most of the work is done, but there are some test cases going to be added, and some refactoring needs to be done. It's under review. With this patch merged, the file system gateways like NFS-Ganesha can invoke read interfaces without passing a pointer to the array of IOX structures. Instead, it would just pass a null putter with the number of bytes that it wants to read. And this would also mean that the writes can go through messenger without a data copy. What's next? So we can have some Samba integration as well. Samba currently does synchronous I/O. As far as I know, they are using a Libcephfs proxy to do this. So Samba can make use of it and also, leverage the I/O and the throughput. Yeah, that's it. Thank you, folks. Thanks for joining.